Okay, guys, I'm going to do a Unit 3 review right now very quickly. Shh. If I could ask you guys just to keep it down. You've been working great today. Keep it up. So Unit 3, which is called Polynomials, first of all, it involves some language. You need to know what the word polynomial means. And basically, poly means many, and a nomial is a term. And a term has a bunch of parts. For example, a term has, could you just put up your hand if you need a Unit 1 outline? Rihanna will come around. A term has a number in front, which we call the coefficient. It has a letter, which we call the variable. And it has an exponent, which we've already practiced from a previous unit. This is called a term. Now, of course, if you've got more than one term, like 3x squared plus x minus 2, you need to realize that each of these terms has different parts to it, and we use algebra tiles to understand that 3x squared are 3 big squares, 1x is a small positive rectangle, and a negative 2 would be 2 tiny little colored chips. In other words, these 3 shapes cannot be combined. So these 3 shapes are separated. You've got 3 terms. So Seb, you need to put that away, unless I'm going to collect it. Same with you, Lars. Whatever. You got to get working on what you need to get working on. So if you look up here, these 3 terms cannot be combined into one group because there's 3 separate groups of shapes. So this is called a term that has 3 terms. It's called a trinomial. And you need to know that the highest exponent is its degree. So this is a second degree trinomial. Okay? And then after that, it's about working with polynomials. So when I say working with polynomials, you are taking this polynomial, and I'm going to ask you to add and subtract. And then I'll talk about multiplying and dividing next. All right, let's talk about adding and subtracting. Well, we know that these polynomials have shapes. Therefore, only the same shape can be combined. These are called like terms. What gives a term like is the same variable, x, and the same exponent. So 3x squared needs to be combined to x squared. Now, there's no number in front of x squared, which means there's a 1x squared. Of course, 3x squared plus 1x squared is 4x squared. Notice we're going to do the same thing in a minute when we subtract, and I made a mistake, by the way. This should say squared. All right, let's go back to the previous question. This term has an x. What term over here has an x? That does. Now, even though we're adding, watch out, we're doing negative numbers. This is 1x plus negative 3x. Notice what's in front here, negative 3. 1 plus negative 3. 1 plus negative 3, that's negative 2x. And then finally, and sometimes I'll do different shapes around the like terms, I have negative 2 plus 1. That ends up being negative 1. So that's how you add. Very similar when you subtract. Just watch out for your rules for subtracting. Okay? So Rihanna? If you look up here, we need to subtract 3x squared and 2x squared. Notice we're subtracting. 3 minus 2 is 1x squared. And here's the tricky one. What's 1x minus negative 3? I'll write it down. 1x minus negative 3. So that's why in Unit 1 I spent so much time reviewing. Minus a negative. Minus a negative is a plus. And of course 1x plus 3x will be positive 4x. Okay, so that's adding, subtracting polynomials and naming them, classifying them, etc. The other thing, other than algebra tiles, which is on there, which I'm kind of modeling and talking about as we go, is multiplying and dividing. So both multiplying and dividing is kind of like the distributive property. So let's talk about multiplying. You can have something in front of a bracket, and there'll be no sign between the algebra and the bracket. With division, you're going to have possibly a bracket, maybe not, but you'll have definitely a division sign or a line underneath them with something below it. So both of these are having to do with the distributive property. The one that has something in front, that's multiplication. And notice we distribute. In other words, they both get multiplied by 2x. Now you have to be careful here. This is 2x times 3x. We're not adding. We're not going to say 5x. So let's write it out. 2x times 3x. Notice, I can rearrange this. I can put the 2 and the 3 together, and I can put the two x's side by side. In other words, 6, what do you call it when there's two x's side by side? X to the first times x to the first, that's x to the second. So the exponents do change when you're multiplying. Also, don't forget the 5. 2x times 5 is just 10x. All right, so that's multiplying. And then the last thing is division. Division is very similar, except instead of multiplying them both by the same thing, you divide them both by the same thing. All right, so we're going to divide 5x squared by 5x minus 10x, also divide by 5x. Notice the line goes under them both. So how do you divide? Same thing. You're going to divide the numbers, 5 divided by 5, which is 1, and you're going to divide the letters. How do you divide letters? Well, if you have x times x in the top, and there's an x in the bottom, we already learned with fractions that common factors cancel. Another way is in our last unit, we did exponent rules. And the rule for division is subtraction. So x squared divided by x to the first is going to be 1x to the first minus, watch out for this one, 10 divided by 5 is 2. And I know Seb is rewriting exponents, but check this out. X to the first divided by x to the first. Well, first you should see they cancel. But if you did exponents, you'd subtract and get x to the 0. And he needs to remember anything to the 0 is 1. So it's gone. So that will be your answer when you divide. So those of you rewriting Unit 3 polynomials, you need to know the name of them, the degree, the language, how to add, how to subtract using algebra tiles, how to multiply, and how to divide. So those are your examples there. You can use your Unit 3 outline or the review puzzle you got last day.